Okay, guys, week 8 physics quiz. This quiz, the first 15 questions, they're hard, but then it's just like the periodic. Okay, let's start. The bob of a pendulum swings between a point P on the extreme right and a point Q on the extreme left. R is the midpoint of the path of the bob. Which of the following are true? Okay, guys, let me explain what's happening here. You have a pendulum, yeah, which is a string with a mass attached to the end of it. You have R, you have P, like when it swings up, it's gonna be at P. And if it swings to the other side, it's gonna be at Q. Okay? So while it's going up, potential energy is increasing and kinetic energy is decreasing. While it's going down, potential energy is decreasing and kinetic energy is increasing because it speeds up while going down and slows down while going up. And also while it's at Q, like it goes up and then the kinetic energy is equal to 0 and then it goes back down because it needs to stop before it goes back. Like it can't just immediately go back, it has to go like this. Okay, let's see. At a point between P and R, the bob possesses both potential and kinetic energy. Oh yeah, guys, also one more thing. You need to know mechanical energy is equal to potential energy plus kinetic energy. Potential energy can be gravitation, potential elastic, potential anything. But for now, we're just taking gravitation potential. So that's the only thing you need to know about. Okay, so at any point between P and R, this is P, this is R, the bob possesses both potential and kinetic. So let's say it's going up, so it has speed, that's why it's going up. And it's up a bit, so the gravitational potential energy is going to be this much, the amount it went up. And also if it's going down, it's going to be the same thing. So yeah, that one's correct. Kinetic energy of the bob is 0 at R. So no, it's actually the highest at R because it just swung down and the potential energy is going to be at its lowest. So kinetic energy is going to be at its highest. Because if you decrease this one, then this one has to increase because mechanical energy is always conserved in a closed system where no external forces acted on it. So is 0 at R? No, it's the max, it's the highest it can be at R. At point R, the bob possesses both kinetic and thermal energies. This question has nothing to do with thermal energy. The kinetic energy of the bob is maximum at Q. No, it's actually 0 at Q. Because it stops moving for a second and then it goes back down. So it's actually 0 at Q. The potential energy of the bob is maximum at P. Yeah, it's the maximum at P and Q because that's the highest it can go. Okay. Question 2. Also let me talk about the pulley system. A pulley system, let's say you have a mass attached to a string, yeah. So you have a pulley, it can either change the direction of motion, you're applying a force this way, for example, and the thing is being lifted, the mass is being lifted up. It can also be like this, you're applying the force down and the mass would also still be being lifted up. But there's another type of pulley. Let's say you have this. Okay, there's a type that's like this. So you double the distance which the force is being applied. So a pulley actually keeps the work constant, and work is equal to force times the distance. So you actually double the distance, spread it across this side and this side. So let's say you apply a force of 5 newtons up, this will be raised by 10 newtons because the work is conserved. Because 5 newtons here and then the distance is halved. So it actually, yeah. But you can only do one at a time. You can't change the direction of motion and the force. But if you want to do both, you just add another like pulley here and make it like this. And then it'd be like two pulleys in the system. Okay, I solved the question. A pulley can be used to reduce the amount of force needed to lift the load. Yeah, in this case, a pulley decreases the amount of work needed to lift the load. No, work stays constant because you double the distance, but you decrease the load. A pulley can be used to change the direction of motion. Yeah, in this case, a pulley is a grooved wheel with a rope looped over it. Yeah, this is the wheel and the rope is looped over it. A pulley is always fixed. No, it can move. It can be attached to like a moving system. Which of the following are examples on reducing convection? Okay. Walking in windy weather, the windy weather would blow on you, would like hit you, the wind. Okay, let's say the wind hits you. So then the cold air hits you, and then let's say yellows the heat from your body. Let's say this is you. Oh, it's so unclear. Wait. Let's say this is you. Okay, and your body releases heat. The cold air would hit you and it would move the hot air out of the way. So like it's gonna forcefully increase convection around you. So no. Opening the window while the heater is on. No, that's gonna increase convection because you have hot, the heater, and cold, the window. It's not necessarily cold, but it's gonna be colder than the heater. It's gonna go to the cold and then the convection current is gonna happen. So this one no. And this one no. Turning on a fan also blows on you. Like let's say this is same case as the wind. Fan also blows on you, so no. Wearing woolen clothes. Yeah, because woolen clothes has small gaps of air in it, and convection can't happen in small gaps of air. It needs space. So yeah, locked up feathers on a body. Same case as the woolen clothes. There's small gaps of air in it. Okay. Consider the cross-section area of a vacuum flask. Which of the following statements concerning heat insulation in the vacuum flask are true? Vacuum between the double glass walls prevents conduction. Yes, it does. Because conduction can happen in solid, can happen in liquids, can happen in gases, but it can't happen in a vacuum. The only one that can travel in a vacuum is radiation. But here, because also the sun's rays, they travel in a vacuum to reach Earth. But here, it's silver surface, so the rays, they would come, and they would reflect off, because silver is a reflective material. So it would reflect the radiation. So even radiation wouldn't get in. Okay, so vacuum between the double gases, yes, it does prevent conduction. Heat loss can only occur when the stopper is removed. Yes, because this is all insulating. When the stopper is removed, then heat can escape. Let's say you don't have the stopper, heat is just gonna escape. Heat loss through radiation is reduced by the two silver coatings. Yes, because they reflect the radiation. I explained this 2 seconds. They reflect the radiation. Convection is totally prevented by the outer case of the flask. No, you need the stopper. Silver coating helps release the heat from the flask. No. Okay. Which techniques are effective to keep a house warm during winter? Outdoor ventilation, it's winter, it will become colder. Double glazing, yes, this is like when you have two glasses, and air is the best insulator. But air also transfers heat by convection. But if it's a tight space like this, the current can't happen. It doesn't have space to happen. So yeah, window lubrication. How would that that just changes how smooth it is opening the window, and it doesn't have anything to do with insulating the house. Loft insulation. Loft is a material. It's kind of like hay. It's like this kind of. There's small gaps of air in it, and it's an insulator. So yeah. Effective floor covering. Yeah. Also the same case. It's just a good insulator. The object that increased the potential energy the greatest amount is object. Okay, so guys, the way you calculate potential energy, it's mgh. So g is always going to be 10, so it should cancel out for all of them. We don't need to do it. So for the first one, it would be 4 times 10, so 40. For b, it would be 3 times 1.5, so 4.5 times 10 is 45. For this one, 2 times 2.5 would be 5 times 10, so 50. And this 1 times 3, it would be 30, because you multiply all of them by 10. So the greatest one is C at 150. To C of 50 joules. Okay, if the objects are now allowed to fall back onto the ground, which one will be traveling the fastest when it reaches the ground? So guys, let's assume here that this is a closed system. So mechanical energy would be conserved. So if mechanical energy is conserved, that means potential energy initial is equal to kinetic energy final. This also works the opposite way. So kinetic energy initial is also equal to potential energy final. So here we have the initial potential energy for all of them and the kinetic energy. So first let me just erase this. This is the one we're gonna use because we have the initial potential energy for all. Okay, first potential energy is mgh, yeah, and kinetic energy is 1/2 mv squared. So we just want to simplify this first. So m would cancel out, Take 1/2 to the other side, so it would be 2gh equals v squared. So g is 10 for everything, so you can just cancel it out. So which one has the highest height? Because 2 height is gonna equal v squared, and we want the highest v. So which one has the highest height? It's 3 meters. So it's gonna be object D. Like I can just say it's the one with the highest height, but also like I want you guys to understand. The bob of a pendulum is 10 centimeters above the ground level when the bob is at equilibrium. When swinging, the bob passes through the lowest point with a speed of 2 meters per second. G equals 10 newtons per kilogram. Newtons per kilogram is the same as the gravitational acceleration. So it's gonna be the same as the height of the bob above the ground when it first comes to rest, 1 decimal. Okay guys, question, it's a bit hard, but it's okay, just focus. So again, we said kinetic energy initial is equal to potential energy final. It doesn't matter which one's final, which one's initial, but here we're just gonna use it like this, okay? So the initial kinetic energy of the bob is 1/2 mass times 2, 1/2 mv squared. Speed is 2, so it's gonna be times 2. This is the v squared equals the final potential energy. Potential energy is mgh. The m's can cancel out, And let's just simplify this. 2 squared is 4. 4 times 1 over 2 is 2, so you're going to have 2 equals GH, right? G is 10, so you have 2 equals 10H. Put this on your calculator. Wait, give me 2 seconds. I'll put it on my calculator. To find H, so 2 equals 10x, shift, solve. You get H is 0.2. 0.2 meters. So now we know that this is the bob, yeah? When it swings up, it's 0.2 meters higher than when it's here. But they said when it's at equilibrium, it's 10 centimeters above the ground. And they want it here how high it is above the ground. They want it here how high it is above the ground. So you're going to add the 0.2 to the 10 centimeters. 10 centimeters to meters. 10 centimeters over 100 to get it to meters is 0.1 meters. So 0.1, because this distance from this to the ground, plus 0.2 equals 3. So the answer is, oh no, wait, 0.3, 0.3, 0.3. The answer is 0.3. Okay, a box of mass 4 kilograms initially at rest is pushed to the right with a force of 20 newtons for 4 meters on a frictionless level surface. Okay, so frictionless surface, which means there's no friction. So you push to the right. Obviously, you have the mass, and the normal is always equal to the mass. And it's pushing 4 meters to the right. Normally, you would have friction, but they said frictionless surface. Mechanical energy, I said it's conserved if it's a closed system. Here, it's being pushed, so an external force, the push, is acting on the system. So it's not a closed system, so the mechanical energy is not conserved since there's an external force applied. The final kinetic energy of the box, okay. So the way you find kinetic energy, it's work. So work equals delta kinetic energy. Okay. And here it started from rest. So yeah, wait, let's just find the work first. Work, it's easy. It's force times distance. So 20 force times distance, 4 meters. It's gonna equal 80 joules. Okay, so also delta kinetic energy, which is kinetic energy final. Minus kinetic energy initially, it's initially at rest, so it's minus 0 equals 80. So kinetic energy final is equal 80. And do they want kinetic energy? Yeah, the final kinetic energy of the box is 80 joules. How do you find the speed? You do 80. We found kinetic energy, yeah? Kinetic energy is equal to 1 over 2 mv squared. Kinetic energy is equal to 80. equals 1 over 2, 4 is the mass, v squared. So if you guys put it on your calculator, give me 2 seconds. 80 equals 1 over 2 times 4 times v squared. You get v is equal to 6.324, and it goes on. Let's see, to 1 decimal, so 6.3. 6.3. Yeah, like this is the point of the quiz that's kind of hard, like from 8 to around like 15-ish is what it's like. Power is defined as energy per unit time, per time unit. The power is watts. 1 watt is 1 joule, because joules is energy per unit time, like time is second. So 1 watt is 1 joule per second. Okay, a car is traveling at a constant speed on a horizontal road against a constant force of 550 newtons. Okay, guys, this question it's a bit hard. So constant speed, which means kinetic, the change in kinetic energy is 0, because if you do K final minus K initial, K final and K initial are going to be this, kinetic energy final and kinetic energy initial are going to be the same thing, because it's constant. There's no change. So 0 is going to equal the force of the engine, or the work, I mean, my bad. Work of the engine plus work of friction. But work of friction, it's gonna be negative 550, because it's against a resistance, like it's against the direction of motion. So 0 equals work of the engine minus 550. That means work of the engine, if you put it on your calculator, it's gonna equal 550. Let's just keep that up here because we're gonna use it later. It's like continue solving the question. Work of the engine equals 550. Okay, let's just erase this. Okay, so the work done by the car engine. So work is force. Oh no, wait. Oh, guys, this isn't the work to get the force, my bad. And the other one was also the force, my bad. I kind of confused you guys. Okay, so work is force, 550. Oh, wait, guys, my bad. Wait, I'm making so much mistakes. Okay, wait, so 550 times the distance. How do you find the distance? It's speed times the time. So 20 times 12. So you put that on your calculator. You get 550 times 20 times 12. You get 132,000,000. Divide by 1,000 because it's in kilojoules, so it's gonna be 132. And the power of the engine is just work or energy, so the kilojoules, over time. So 132 over the 12 seconds. 12 seconds. With the S looks like about 132 over 12. The answer is 11 kilowatts. You don't need to divide by 1000 anything because it's already in kilojoules. So 11, yeah. Okay, a man mass 60 kg runs up a flight of 30 steps in 20 seconds. Take G equals 10 meters per second squared, knowing that the height of each step is 15 centimeters. Okay, so what do they want? The power. So they want the work over the time. Power equals work over time. Time is 20 seconds. So, yeah, but how do we find the work? Work is equal to mgh, right? By the way, guys, it's the same as force times distance. Force times distance. Because mg is just the force up. Your mg is just your weight, so it's the force pushing up. The force you're producing to push that weight up. And the height is how high it is, which is basically the distance up. Okay, so mgh is the same as force times distance. Okay, so the mass 60 kg equals 60 kg gravity times 10, and the height, so 30 steps, each step is 15 centimeters, which is 0.15 meters. Okay guys, don't get confused and put centimeters. 0.15 meters. You do that, it's gonna equal let me do it on my calculator. Give me 2 seconds. 60 times 10 times 30 times 0.15. You're gonna do that, you're gonna get 2,700, and that's the work. And they want power is work over time, so the time is 20 seconds. You get 135. And the answer is 135. How many joules are in 1 kilowatts times hour? Okay guys, you don't even have to memorize this one. 1 watt is 1 joule, yeah? No, what was 1 joule per second? And 1 kilowatts is 1000 joules per second, right? And you multiply that by an hour. It makes, you multiply that by an hour. An hour is how many seconds? An hour is 60 minutes. Each minute is 60 seconds. So it's gonna be equal to 1000 times 60 times 60. You get a big number again. 3, 6, 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. So this is how much it is. So 3.6 megajoules. So you divide by a million. So you divide by 10 to the power of 6. Yeah, it's gonna be 3.6 megajoules. Okay guys, look. Mass m slides from rest down a smooth incline of length L, moving down a height. Choose the correct answer to complete the sentences below. The height h of the incline in terms of L, and the angle of inclination is... Okay, look. Let's say we have an incline, yeah? Let's say it's the height is h. Length of the inclination is L, right? This is the right angle. And this is the angle we're trying to... This is the angle we're trying to find. Okay? So, if you look at the options... Oh yeah, I love these options. Picture, 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 picture. The height h of the incline in terms of L. Okay, so okay, so we're gonna use sine because you have the opposite and you have the hypotenuse. So sine theta equals opposite, which is the height, over the hypotenuse, which is L. But they want it in terms of h. So you take L to the other side. It's gonna be L sine theta equals h. You're gonna take it out. So the answer is L sine theta. Are the options fixed? Nope. Okay, I just write it said because it doesn't want to work. L sine theta. Now, the loss of gravitational potential energy in terms of L, M, the gravitational potential energy strength of G. Okay, guys, look. So, we have H is L sine theta. Gravitational potential energy is M, G, H. And the loss of gravitational potential energy is because it's sliding down the incline. So that's going to be negative. But they want it in terms of L, M, and G. So it's going to be negative M, G. And instead of the H, you're going to put L sine theta. L sine theta. You're gonna get negative mgl sine theta. Negative mgl sine theta. Okay, guys, that's the answer. But yeah, the options they don't want to work. Here's they work. No, the options don't work in any. In both. An electric motor of power 320 pumps water up to a height of 2 meters at a rate of 10 decimeter cubed per second. Yes, this question, like, I don't remember taking this in class, but it's okay, I'll explain. So efficiency, we took efficiency in class, but like the way you get it in this question specifically, I don't think we took it. Okay, so efficiency equals power out, like the output, over power n. So power n is just 320. Okay, power n is just 320. Pumps water up to a height of 2 meters at a rate of 10 decimeters cubed. Okay, how do you find the power out, like, from that? So, okay, guys, look. The density of water is 1 kilogram per decimeter cubed. Okay, this should be given. I don't know why it's not given, but okay. And how are you gonna find work? So work is m g h. Okay, g and h are g is 10, h is 2. H is 2. How do you find the mass of water being pumped? So you need to do 10 decimeters cubed times 1 kilogram per decimeter. And if you think about it, like, it does make sense, because look, decimeter cubed per second times kilogram per decimeter. If you cancel out the decimeters, you get kilogram per second, yeah? And if we don't use power, like let's say we don't use the work here, we just go straight for the power, it's gonna be, this is the work over the time, right? So it's gonna be GH, so 10 times 2. We'll just use GH as 20 because we already have, okay? So power is gonna equal mass over time. Okay, what power is equals to mass over time? What's mass over time? Kilograms per second, okay? Times GH. What's GH? 10 times 2. So how do we find mass over time? We said we multiply the decimeters per second, so 10 times 1. So mass over time is 10. Okay? Because 10 times 1. Damn, but this question is messy. Oh my god. So 10 times 2, so times 20. That's gonna equal 200. And we said efficiency is power out over power in, so power out is 200 over power in, which is 320. Now when you solve this, you're gonna get 200 over 320. You're gonna get 0.625, and they wanted to do decimal places. 0.625 to 2 decimal places is approximately 0.63. Okay guys, this question is so confusing, and like I feel like my explanation was a bit also confusing, so my bad guys, but I don't know how to explain better than this. Okay, so 0.63. An experimenter measures when the rope is pulled 2 meters out of a system of pulleys, piano goes up by 1 meter. He measures his effort E as 300 newtons and the mass of the piano as 120 kilograms. Okay guys, look. So the force he did is 2 meters by 300 newtons, so force times distance, so his work is 300 newtons for 2 meters, so 3 force times distance. Work is conserved. This is work. Force times distance. Distance is 2. So it's 600, yeah? And the work he outputted is force times distance also, but the distance is 1 meter, yeah. 1 meter. Because it says here. But 120 kilograms times the what's it called? The gravitational acceleration, so times 10. That's equal to 1,200. So if you put in 600 joules, you're not gonna get out 1,200 joules. That's not how it works. So let's say this. It is impossible because the output is more than the input, yeah. Okay, guys, this one, it might look complicated, but it's actually very easy. Look, so the formula is load times distance of the load, distance between the load and this. So it's gonna be D1 here, equals effort times the distance between the effort and the bulk. So load is what we're trying to find, so load times distance between the loads, so D1, so 30, equals effort, so 150 times 90. You're gonna get, if you do shift solve, you're gonna get L equals to 450. So the answer is 450. The figure below shows a compound strip of copper and iron. The strip is straight at room temperature. The coefficient of thermal linear expansion of copper is greater than that of iron. The bimetallic strip is heated. Okay, look. Coefficient of linear expansion of copper is greater, so it would bend more. This one would bend less. So it's gonna curve around it, yeah? So it's gonna bend upwards. Okay, guys, we spent so long on this quiz. I know the video is probably gonna be long because of these few questions right here. But now we're at the easy part, so let's just fly through it, yeah? A red woolen jacket, a steel sword, and a black piece of coal have been placed in an insulated room for a sufficiently long time. Which object would be the coldest? So, if they've been placed in a room for a sufficiently long time, then they'd all be at the temperature of the room. Because the heat transferred from the hot stuff to the cold stuff, the heat would just move around the room. Okay, it's gonna all be equal at the end, so they'd all be equal to the same temperature. They all have the same temperature. They're all at thermal equilibrium. What happens when two objects reach thermal equilibrium? They both have the same temperature. Heat transfer between the bodies stops because they both have the same temperature. If you have 10 degrees Celsius and 10 degrees Celsius, yeah, heat is not gonna go from this object to this object. This one's not gonna be 9 and 11. No, it's just gonna, they're just gonna both stay at 10 at 10 because they're both at the same temperature, which means they have thermal equilibrium. Fur coats keep their own ears warmer if they are worn inside out because of trapped air forms a very good insulator. Yes, we explained it so many times. An electric filament lamp with clear glass bulbs is switched on and gives a bright light. The bulb contains a small quantity of argon. Identify the process by which heat is lost from the filament lamp in each case. The filament of the lamp emits radiant energy. Already, you could just think radiation is radiant energy at the beginning, thus heating up the gas, which in turn heats the glass bulb. The glass bulb becomes hot and again starts to emit radiant energy. It's not okay, gas is by radiation because it's emitting radiation. The lamp filament gets hot when the bulb is switched on, heating the argon gas, or that is in contact with the filament, thus heating the glass bulb. Contact, automatically conduction. As the argon gas around the filament gets hot, its density decreases. So it gets hot, density decreases, it goes up. And then, yeah, The argon gas in the filament rises and is replaced with cool argon gas. Yeah, so it's basically just the convection current. So this is convection by convection. Okay. This it's in the periodic quiz also. The table below provides the linear expansion coefficients of several metals. The combination of these methods are used to make bimetallic strip thermometers. In order to make the thermometer the largest bend, so you're gonna have the highest coefficient with the least coefficient. So it's gonna be aluminum and iron, so it would bend the most. If the bend the most means the greatest difference. Aluminum strip and iron strip. Okay, another bimetallic strip is made from materials listed in the table. The bimetallic strip is heated and bends as shown below. Strip 1 is made of silver, and strip 1 bends less. So this one has a higher coefficient. This one has a lower coefficient. So what has a higher coefficient than silver? Let me check the table. Silver 18. Okay, aluminum. Aluminum. This one's also in the periodic quiz. So yeah, guys, at the end of the quiz is just basically like the periodic. An aluminum rod whose length is 0 degrees at 1,200 centimeters is heated to a temperature of 80 degrees. The coefficient of linear expansion is 24 times 10 to the power of negative 6 k to the power of negative 1. K to the power of negative 1, by the way, guys, if you see, is just the same as this over k. Okay, so the formula I explained in the other quiz also. It's delta L equals 1,200, because the L initial times the coefficient of linear expansion. So 24 times 10 to the power of negative 6. I need to get better at writing, that takes too long. Times T final minus T initial, 80 minus 0 is just 80 times 80. You do that, you're gonna get delta L equals to 2.304, right? So delta L, which is 2.304, because they want the length at the end, so they want L final. 2.304 is equal to L final minus the length initial. Length initial, it's just 1,200, it's given. So shift solve, you get 1202.304, and they want to do the nearest integer, so just 1202. Liquid mercury. Metals are good conductors because they have free electrons. So mercury is a metal. Copper is a metal. Fiberglass is a poor conductor. It's sometimes used as an insulator. Iron is a good conductor because it's a metal. Water vapor. Gases and liquids are usually bad conductors. So water vapor is a poor conductor. Contains free electrons. Good a conductor. Contains only combined electrons. Poor conductor. These two are the opposite. Is in gaseous state. Poor conductor. Contains pockets of air. Poor conductor because that's pockets of gas. So it can make it a poor conductor because it still has gas in it. Is a metal. Good conductor. Gas physics, it's not like memorizing. It's like understanding. The use of double glazing window panes reduces the amount of heat escaping the house through. Okay, guys, I explained this in like the first few questions. Double glazing glass, no space for convection, so it's gonna reduce it through convection. Convection. A room filled with air is heated by a radiator. Like radiation, like use your eyes. The Earth is heated by sun ray. Oh, wait, guys. My mistake. This one's convection, because it's a room filled with air. So, like, you have the radiator. Let's say this is the radiator. It's heating the air around it, so the air is hot, so it's going up and it's making the convection currents. My bad, guys, my bad. Just ignore that I said, like, use your eyes. Earth heated by the sun rays, that's radiation, because the only radiation can travel through the vacuum. A cooking pan is heated by electric heater. Conduction, because they're in contact. Conduction can happen in solids, liquids, or gases. Radiation can happen in solids, liquid, or gases. But convection, it's only in fluids, so gases and liquids. Because I can't have a current in the solid. But you can have contact between solid, liquids, and gases, and you can have radiation. Radiation can do everything, even back. Predominant species, the transfer process which temperature of the air above the gas burner. Okay, see this one? The air, it's heated up, it pushes up, because that's how the convection current is. Yeah, you guys probably can't see that. You have the hot air, yeah? It goes up, pushes up. That's why the thing goes up. The predominant heat transfer process will increase the temperature of the gas burner is convection. Convection, okay. In which of the following media? Liquids, gases, it's just the same as this. Wait, well, also, why did they make it like this? Like, it looks so complicated. What's this? Some witchcraft. Liquid, gas. Oh, UFO heated, a UFO heater, yeah, they're just making stuff up now. Convert electric energy to produce infrared electromagnetic waves. Infrared electromagnetic waves are radiation. Also, yeah, if they said next to it, then it's radiation, because convection doesn't travel to the side, it goes up. Radiation. We did this last year, but I don't know why it's in this quiz. Why are the pipes made of copper? I don't know. It's a good conductor of heat. Also, the other two are wrong. Yeah. Look, so basically you want the sunlight to go in, you want the copper to heat up and the water inside it to heat up, so then that could like be used to produce energy. Okay. Why are the pipes in the metal backing sheet painted black? Because black is a good absorber of light. Yeah, black color absorbs light. White color and shiny stuff reflect it. Why is an insulating material attached to the back metal blacking sheet so the heat doesn't go in the house? Like, let's say you have this solar panel on your roof, you don't want your house also to be hot. So so basically the answer I thought of is not even in the options. Okay, nice. No. To prevent the pipe from exploding, I think it's to reduce heat loss to surroundings. I think. Probably gonna get this one. Okay. Why does the presence of glass sheet increase the energy collected by water? Trapped air inside the glass sheet increase the energy collected. That's not what they're asking. Why does it do that? A glass is a good conductor. Okay, no, this is the only one that kind of makes sense. Okay, inshallah, I got that last question. Okay, so this one, does it work now? What did we get for this one? L sine theta and negative mgl sine theta. L sine theta is h, it's negative mgh, but you just replace the h with sine.